Hello and welcome to this section of the tutorial where we're going to continue working with vectors, and specifically we're going to learn two very important ways to construct vectors. And I'll just jump right into it and I think you'll understand. Up until now, all of the vectors that we've been constructing, we've basically typed in. I mean, this is the case when you're doing your physics homework and you know that you need a vector 3, 4, 5 or something like that. We've already talked about that. You can type your vectors in, type your elements in, MATLAB will accept it. But there are many cases when you need to construct a vector or construct some values that are going to go into a list, which are basically going to go into a vector, but you don't really want to type them all out. Sometimes it might follow, a nice repetitive pattern. And for instance, maybe you want to construct a vector that goes from 0, the minimum value, to 10, maximum value, in increments of 0.1, right? So something like this, for instance. Let's take a vector b and let's go ahead and define it to be the following. We open a bracket just like we normally do, and we'll do something like 0, colon, 3. Let's do a 3, make it a little bit smaller. 0, colon, 0.1, colon, 3. So the way you do this is you're telling MATLAB, construct a vector from 0 to 3, the very last value. Basically the first value and the last value are the end caps of the vector. So you're going from 0 to 3, but you want the increment to be 0.1 between each element. So when you do that, you get lots and lots of values back. So notice the first element 0, which is what we told it. The second element 0.1, because that's our increment. And then each element we're incrementing by 0.1. We keep incrementing all the way until we get to 3, which is where we told it to stop. So this would be much faster if you knew you just needed a vector for some reason with equally spaced elements. This is the fastest way to do it. Now notice if I recall that vector and then go and actually take out the middle part, so that I just have 0, colon, 3, MATLAB is going to assume that you want the spacing to be a 1 between adjacent elements. So 0 to 3, right? 0 to 7. It's going to create a vector with 7 elements. 0, to 5. It's going to create a vector with 5 elements equally spaced with a unit of 1. So you can sort of insert the 1 in there. Whatever you have in the middle is going to be the increment between adjacent elements. And of course I can change that to something like 0.5. Let me change this to 2 to make it a little bit easier. So now I'm defining a vector. I'm assigning it to variable b. It's going to go from 0 to 2 in increments of 0.5 between each adjacent elements. So I have 0, 0.5, 1, 1.5, and 2. So you can create very large variables like that. So let's say we have a vector s. We want to do from, let's say we want to do it from negative, 218. And we want to go in increments of 0.25, and we want to have the last value be negative, 100, something like that. So what we have here, you close it off in a bracket. So now we're creating a vector. The smallest value is going to, or the starting value, I should say, is going to be negative 218. Then we're going to increment by 0.25 each time, counting up until we get to negative 100. So there's a lot of elements here, and you see when you hit enter there, MATLAB gives an entire book of these things back. So if you wanted to do that, for instance, and not actually echo the output out, let me clear the screen just to kind of remind you. If we wanted to define that but not actually echo everything to the screen, this is a great example of when you might want to suppress the output. Just put a semicolon at the end. The definition takes place, everything is done, it just doesn't spill it back to the screen for you. If you look over to your workspace area, variable s is created, the vector s, and it tells you it's 1x473. What this means is it's one row, 473 columns. Remember what I told you before. Everything's really a matrix in MATLAB. So we're calling in these things vectors that are just basically matrices with one row. So that's why it says it's got one row in this matrix, 473 columns, because that's each little sort of column is every little element that's listed here. Each value is at double precision. That we've already talked about. That's the default thing in MATLAB. If you go over here, it tells you the minimum value in this vector is negative 218. The maximum value is 100. Now, of course, we can extract values out of s all day long. What if we want the first element? The very first element should be negative 218 because that's what we started with. What if you wanted the 19th element? Then that would return the 19th element. What if you wanted the 57th element, it would give you the 57th element, and so on. So you could extract things like that. Now this is a vector with an enormous number of elements, 473 elements to be exact. If you wanted to look at it without spilling it all to the screen like MATLAB does when you type in S and it just spills everything to the screen, that's kind of ugly, then what you can do is go over here to the workspace and just double click on this variable and it'll open it up in like a little spreadsheet here. So this is sort of a nice way to scroll through and say, okay, well, element 29 is this. You know, you can go all the way to the end here and see how many elements you have and so on. You can look at the first element, the last element. You can even change values here if you really wanted to, because once the definition takes place, that's what's stored in variable S, and you can make changes there if you wish. So that is very important, and you'll be using that a lot in MATLAB. Creating these little cheap little vectors, so to speak, that have a constant increment between adjacent elements. They pop up in uses a lot, and we'll talk about exactly why they're useful later. All right, so now what we're going to do is introduce another very powerful way to automatically create these nice evenly spaced vectors. It's very similar to what we just talked about, but there's a pretty significant little difference here. Let's define a variable t, and instead of putting some brackets here and typing in some stuff to increment and create our vector for us, we're going to use a command called linspace. It stands for linear spacing. Let me show you how it works. If we put in something like this, 0, 10, 2, then what happens here is it's going to create a vector that's the lowest value, the first value is going to be 0, the final value is going to be 10, and the 2 here is not an increment between adjacent elements. The 2 tells MATLAB how many elements I want in my final vector. So if I hit enter, MATLAB is going to return a vector with only 2 elements because I have a 2 here, and the endpoints are 0 and 10. So it creates a linear spacing between adjacent elements. I think you'll see the pattern if I change this to a 3. So now I have a vector that has 3 evenly spaced elements from 0 to 10. So obviously if I have 0 and 10 as endpoints, I need a third element as per my command here. Then the third element must be evenly spaced in the middle. That would be a 5. Now if I change this over to a 4, then I'm going to have a vector that goes from 0 to 10 with 4 elements evenly spaced. And now things look a little more interesting because my vector goes from 0 to 10 all right, but MATLAB calculates that the second element has to be here and the third element has to be here so as to give me an even spacing between adjacent elements. And if I go to 5, you see I'm back to nice numbers again, because if I have 0 to 10 and I chop it into 5 pieces, then I have to have my elements resting here to be evenly spaced. So I think you see the idea here now. When I change it to 7 elements, then basically it's going to chop this interval from 0 to 10 into 7 pieces and try to put the elements into place so that they're all evenly spaced or linearly spaced from one another. So that is another way to create a vector or a listing of numbers, and it just depends on what you're doing, what you might need. In the first case, we're creating a vector like 0, 0.25, 4, something like this. In this case, we're telling MATLAB what the increment should be between adjacent elements. We're giving it the endpoints, but we're also telling MATLAB, I want you to have 0.25 spacing between the elements. And so MATLAB just creates the appropriate number of elements that reach from 0 all the way to 4. Every little increment between each little thing is 0.25 because I specified here in the middle that the increment has to be 0.25. If I use linspace from 0 to 4, then the third number tells MATLAB how many elements, and then it calculates what the increment needs to be between them. So if I have 9 elements between, or I want 9 elements in this vector here, then MATLAB calculates that in order to have 9, then I'm going to have an increment of 0.5 between them. If I have 11 elements, then MATLAB calculates that I have to have this increment between them, but I have 11 elements in that vector there. So they're very, very similar. In one case, you specify the increment, you specify the endpoints in both cases, but in the first case, you specify what the increment is, and then MATLAB constructs the vector. In the second case, you specify the endpoints and how many elements I want, and MATLAB actually calculates the increment for you. So there's various times when you might need to construct a vector. We actually use this when we're plotting functions. When we plot functions later on, we're going to use some of these things. But there's lots of other cases when you might need to create a generic vector to do calculations within the context of MATLAB. So make sure you know how to use these guys. Go back through, use linspace, and use the other methodology that we used to create a vector. Make sure you understand the difference between them. They're very similar, but you might have occasion to use one or the other depending on exactly what you're trying to do.